Welcome to this explainer. I am absolutely thrilled to jump into today's topic because it's something we literally experience every single day. But we almost never stop to actually think about it. I mean, right now, you are experiencing daytime or nighttime for one simple reason: the Earth is rotating. It's just a fundamental fact of our everyday reality. But today we're going to zoom way out. We're setting the stage to explore a massive, truly universal phenomenon. We're going to look at exactly why everything, and I mean absolutely everything in the universe, is locked into this perpetual spinning motion. It's kind of a simple question, right? But it totally shifts how you think about space. Like, why doesn't anything just stand still? Why couldn't the Earth just hang out there in the dark void of space without spinning? Or the moon? I mean, the moon orbits us, sure, but it also spins on its own axis, taking the exact same amount of time for both, which, by the way, is exactly why we only ever see one side of it from down here. But really, why is this movement happening at all? It's like this giant cosmic mystery hiding right in plain sight. Okay, let's dive into this. When you really stop and look at the sheer variety of spinning objects out there, the scale is just staggering. We just talked about the Earth and the moon, but take a look at the sun. The sun rotates too. But here's the wild part. Because it's this massive, churning ball of gas, it doesn't even rotate at the same speed everywhere. The gas actually spins faster at its equator than it does up at the poles. That's something that would be literally impossible for a solid sphere, like a bowling ball. And this exact same behavior scales all the way down too. Asteroids tumbling through the void. Even down to individual microscopic grains of cosmic dust. If you watch them closely enough, they're tumbling and rotating too. We've got all these things, completely different sizes, made of totally different stuff, yet they all share this exact same spinning behavior. Section 1. The universal spin, pushing the limits. 700. Yeah, you heard that right, no typos here. As if our own solar system wasn't crazy enough, when you look at the most extreme environments out in the cosmos, things get intensely wild. Take neutron stars, for example. A neutron star is basically the ultra-dense, leftover core after a massive star explodes, and some of these remnants spin hundreds of times per second. In fact, some have been recorded clocking mind-boggling speeds of over 700 revolutions per single second. To really wrap your head around how fast that is. I mean, we're talking about a cosmic object that is literally heavier than our entire sun. Now just picture a high-speed kitchen blender sitting right there on your counter. That ultra-heavy, massive star is spinning faster than the blades in your blender. I mean, no way, right? But when you start stacking up examples like this, from tiny little tumbling dust grains to massive dead stars whipping around hundreds of times a second, you eventually hit a point where you just have to admit, okay, coincidence is simply not a good explanation anymore. Section 2. The illusion of symmetry. So if this completely inescapable pattern of rotation demands a real physical explanation, it means something in the way matter comes together in the very first place has to generate rotation automatically. To really get this, we've got to talk about perfect symmetry. Perfect symmetry basically means exact, flawless uniformity without any deviation whatsoever. But here is a massive secret of the universe. That kind of perfection, it's practically impossible to find in nature. Even if something looks totally uniform at first glance, like say a sprawling, massive gas cloud in deep space, there are always tiny differences. There might be a little bit more density over here, maybe a little less over there. We're talking about imbalances so small you can barely even measure them, but they exist. A flawlessly symmetrical cloud without these tiny quirks simply doesn't exist in the real universe. So let's see how this actually builds into the rotation we see everywhere. Imagine that huge, slightly imperfect gas cloud. As it begins to slowly contract, right, pulling inward thanks to its own gravity, it's also got these super slight movements drifting in different directions, just because of those tiny unevennesses we just talked about. Well, as this cloud gets smaller and shrinks down, those small, seemingly insignificant movements suddenly become absolutely crucial. They start bumping into and reinforcing each other. Those tiny little imbalances literally snowball, and out of all that chaos, a distinct, clearly recognizable rotational movement is born. Section 3. The ice skater effect. Now, if all that abstract space physics feels just a little hard to visualize, don't sweat it. There is a perfect everyday analogy that translates this beautifully. Contraction equals acceleration. Just think of an Olympic ice skater out there spinning on the ice. When they start their spin, their arms are stretched way out and they're moving at a certain speed. But the exact second they pull their arms inward, contracting their mass closer to their center, they instantly spin so much faster. The universe works exactly the same way. When matter contracts in space, every single tiny, barely measurable rotational movement that was already hanging out in there automatically becomes faster and way more pronounced. Which brings us straight to a really fundamental law of physics, the conservation of angular momentum. Basically, rotational movement doesn't just get lost. It can distribute itself differently, it can change its shape, sure, but it does not just disappear on its own. And that is exactly why a chaotic pile of slightly moving matter doesn't just suddenly stop and freeze as it collapses. Instead, it inevitably automatically organizes itself into a clear, really fast rotation. Section 4. Why it never stops. So, you might be wondering, once these massive objects, these massive planets and stars, actually form and start spinning so incredibly fast, why don't they eventually just slow down and grind to a halt? Well, the absolutely crucial point here is that space has no brakes. Seriously, for a rotating cloud or a planet or a star to suddenly just stop spinning, it would need something to actively push against it. It needs friction, a brake. But in the sheer massive emptiness of empty space, there is practically nothing to act as a brake. We're talking almost zero resistance. And that is the exact reason why our very own Earth has been spinning for billions of years without slowing down in any significant way. Once an object is in motion out there, it tends to just stay in motion over astronomically long periods of time. The spin we're experiencing today, it's basically the exact same rotation that was born billions of years ago. To really appreciate the scale of this whole mechanism, you've got to realize just how universal it is. Whether we're talking about planets, stars, galaxies, or even black holes, it is quite literally the exact same process. Planets form from contracting clouds of dust and gas, and they just take over the rotation that was already laid out in that cloud. Stars, they work the exact same way. Small movements in a giant contracting gas cloud reinforce each other until, boom, the finished star is rotating. Entire galaxies, which are just huge, mind-bending amounts of gas and matter contracting over millions of years, they form massive rotating structures right out of those initial tiny irregularities. Heck, even black holes fit this picture. They often form from the collapse of stars that were already spinning, and the resulting black holes simply inherits that initial rotation. Different sizes, totally different materials, vastly different timelines, but at the core, it's always the exact same process, carrying over that initial movement. Section 5. The true natural state. And this actually leads us to completely flip our intuitive understanding of the physical universe right on its head. I mean, we usually think that resting, standing completely still, is the natural state of things, right? And that movement is some kind of disturbance. But in the cosmos, it's actually the exact opposite. Perfect standstill, an object that doesn't spin at all, would require absolutely perfect, almost impossible conditions. It would literally need a completely symmetrical cloud, without a single tiny irregularity. And since we know that practically doesn't exist, the natural state, the true default setting of our reality, is constant movement and rotation. Because rotation really only needs the absolute tiniest, most microscopic deviation during contraction to kick off, spinning is just an inevitable, automatic result. These tiny deviations are literally everywhere, in every single gas cloud, in every star-forming region across the universe. Almost everything spins. Not because rotation is somehow this universally preferred, magical choice, but simply because standstill is just the more unlikely option. Movement is the standard, period. So I guess the real question isn't why so much is spinning. The real question is why anything wouldn't. The next time you look up at the night sky, or honestly, even if you just look around your seemingly quiet, stationary room right now, just remember that perfect rest is a total illusion. We are living in a universe where everything from the smallest microscopic speck of dust to the absolute largest galaxy is locked in a constant, dizzying cosmic dance. It really leaves you wondering, if absolutely nothing stands still, what else is moving right under your feet without you even realizing it? Anyway, thank you so much for exploring with me today. Keep asking those great questions, and I'll catch you in the next explainer.